Hi everyone, my name is Abel Gray Cantoma. Okay, on this tutorial I'm going to show you how you can come up with your designs, your slab, beam, column, foundation, staircase, using a package called RCD 2000. As a beginner or as a student or a fresh graduate, please, I would advise you start with package like RCD 2000, RCC spreadsheet. They are more like a manual design softwares or packages. Nothing is hidden to you. It's like you are doing everything yourself. Compared to other softwares like Orion, Proto Structure, Tekla, Riser, and the like, so many of them. Sometimes you just input values, and if you without a very good design experience, maybe from a consultancy or under a licensed engineer, you may not be getting it right. So I would advise you to start with package like RCD 2000. Everything is just realistic to you. Okay, this is RCD 2000. You can see staircase, ST, slab. You can see your rip beams, your columns, your base, your beam. So it's just it helps you to come up with your structural designs that has to do with building design, structural designs on building. Okay, this software does not detail for you. It only gives you your design, that's your calculation and all. Okay, we are actually going to use this GA. It's a general arrangement. As you can see, we have 4 different slabs here: slab panel 1, panel 2, 3, and then 4. On this video we are going to focus on slab design. Okay, to design your slab on RCD, okay, if you are actually enjoying what you're seeing, why not give it a thumbs up? Subscribe to this channel for free. I usually post videos on a weekly basis, sometimes on a daily basis, so as to encourage people who are coming up and want to learn how to do these designs. So subscribe is actually free. If you stay to the end of this video, you'll be able to see how I'm going to design this particular general arrangement using your RCD 2000. It's actually very interesting and fun to design, seeing everything you are doing more realistic. Okay, another thing is, if you are using a system of 64-bit, you would have to get this package called DOCSBox. It's it's not that large. On the description of this video, down below of this video, you are going to get the link to this RCD, where you can download this RCD for just a token, and your DOCSBox as low as $1. Okay, to start right now, I'm going to show you. Firstly, you just drag. That's because my system is 64 bits. your system is 32 bits, there's no need for DOCSBox. Okay, when I drag, it opens to me. You can see it's interactive. It's either you use a terminal method or you use an external file method. The external file is actually very faster. It's faster, but you are supposed to attain mastery in the terminal method before you can be able to go into the external file. So on this video, I'm only going to focus on the terminal method because this one is actually interactive. But the disadvantage of this is that you cannot edit at all. You can't edit. Once you make a mistake, you have to start from the scratch. So that is the disadvantage of this. So you press your T, you enter external file, F, you enter. Okay, the output. Okay, let's call it EV page. Password, no password. Job reference. Okay, design date. You don't normally include the particular day, just the month. We are in the month of February, so you can just say February. Hi everyone, in this video I'm going to show you how you can design your slab. Okay, type your T, enter, F, enter. Output name. What do you want it to be saved as? Okay, let's say propose shop design. Okay, no password. Job reference. Job reference is the job number, like the number of the job number, what you want to save your job as, because you may have multiple jobs in your system, and in order for you to easily lay your hands on it faster, it's required you give it a job number. Okay, one. Engineer, let's say J.K. Okay, date March 2020 410. Enter number of panels, 4 panels. Okay, panel ID P1, that's panel 1. Okay, you come back to your drawing. Okay, this is your P1. What do we do here? Now, is it a cantilever? Is it a two-way? Is it a two-way slab? Okay, Okay, your panel 2 is a one-way slab, which is P2. One-way slab, which is 2, simply supported. Panel 3, P3. P3 is a two-way slab, which is 4. Okay, P4. P4 is a one-way slab, which is 2. Okay, for P1 now, it is what? 3, 8, your LX, your LY. I guess you understand the difference. Short span is LX, your long span is LY. Okay, and you understand how to get your one-way slab, your two-way slab. When you a simple calculation, your LY over LX. Okay, your LX is 3830. Your LY is 6230. Your uniformly distributed load. Okay, your uniformly distributed load is gotten from this simple calculation. I hope you understand. 0.15 times 24, that's the density of concrete. This is the value we get. If you are using a finishes of 1.2, partition allowance of 1, total GK, your life load 1.5. Now these values, we assume these are the values we are going to use now for learning sake. Now I'll always refer you back to reinforced concrete design books. You can get one by Victor Oyenuga, RCD 2000, or you can get his book RCD, Simplified Reinforced Concrete Design. Okay, you can get it by Victor Oyenuga, or you can get Mosley and Bongi. Mosley and Bongi is another good one. Okay. Now look at this. Now this is the total value. Now this is the total load. Now we use 10.52. Your depth is 150. Okay. Your span / depth ratio. Okay, this span effective depth ratio for beam and slab. Now for simply supported is usually 20, cantilever 7, continuous 26, two-way is 3. Now, and anytime you have at least one edge discontinuous, you can use 23. Okay, now we are going to use 23. Okay, since our panel 1 is a two-way slab. Okay, now if you check back in this panel 1, you discover that we have this area, or this side, sorry, is discontinuous. This side too is also what? Discontinuous. Now if that is correct, that means we have two adjacent sides that are discontinuous. So we are going to use 4, which is for two adjacent edges discontinuous. For panel 2, which is a one-way slab, as you can see here, the slab span. Now when you are asked of a slab span, it is always the shorter span. Okay, in a one-way slab, it is always the shorter span. Okay, which is 2230. I don't want to go into details of this design, explaining why we are using shorter span. So I will advise you to get the reinforced concrete design books, so as to give you a better understanding. Okay, and then the depth is 150. Okay, that's the depth of the slab is 150. Number of point load, are there point loads on this slab? No. So since there are no point loads, we are going to put 0. Now there could be point load in some cases, whereby you may have a rectangular load, a triangular load, a trapezoidal load acting as a point load. Okay, now whenever you have that, you have to include them. How many number of those point loads? You include them here. If it is 1, you put 1. If it is 2, you put 2. If it is 3, you put 3, like that. Okay. For panel 3, which is a two-way slab, okay, 3830 6230. Okay, 3830 6230. Okay, uniformly distributed load 10.52. The depth 150. Span/depth ratio 23. Okay, for panel 3, now we have one edge that is discontinuous, which is this place. We have one edge that is discontinuous. This particular edge is discontinuous. Sorry, my system is actually slow. Okay, this is one edge that is discontinuous. Okay, and this edge that is discontinuous is the shorter length. Okay, so it's going to be one short edge discontinuous. Okay, which is 2. You can go through it very well and understand. We have interior panel. We have one short edge, one long edge, 2 adjacent. As we go further, you get to understand some of these things. Okay, we have one edge discontinuous. Okay, now for panel 4, which is also a two-way slab, a one-way slab. Sorry, it's a one-way slab. What is the span? Like I told you, the shorter span is the span that we include, which is 1730. Okay, now 1730. Uniformly distributed load 10.52. Your depth is 150. Depth of the slab. Okay, number of point load, there is no point load. Then you press enter. Mind you, you must be very careful when you are using the terminal method, because when you make any mistake, there is no way for you to correct that mistake except you have to start again afresh. So that is why the external method is actually much more easier, faster, and you can just go back and do your corrections and all of that. Okay, it makes your work much more faster, but the terminal method is actually more interactive, and I will suggest it for beginners. Okay, I suggest this for beginners. Okay, you press enter. Okay, after your whole design, the next thing you do is to go back to your RCD, and it has designed it already. Okay, go back to your RCD. Okay, now that particular design is propose shop. Now this is it. It has designed it for us. Okay, now let's go through this. Okay, yeah, so we are using Y12 at 250 millimeter center to center for bottom bars. Your top bar Y12 250 millimeter center to center. On the long span, same reinforcement, same spacing. Okay, for panel 2, this is your panel 2, which is a one-way slab. Okay, we are also using Y12 at 250 spacing, center to center. Okay, that is that. If this video has been helpful to you, why not give it a thumbs up, subscribe to this channel. On our next tutorial, I'm going to be showing you how you can design your beams. Okay, we are still going to maintain the same general arrangement, so as to give you a better understanding of what design is all about. And with a very good knowledge of this package, you can transfer it to any other design software. Okay, stay blessed.